Hello everyone, my name is Alexander Zelenin. Today we will solve the last problem from the arrays section, the hardest one. And maybe if there will be some time, we will go back to one of previous tasks that was solved with non-optimal way, and we'll try to optimize it. So let's go. Array manipulation, success rate 50%. As always, I will not read the task itself, but I will try to explain it by myself. I just had read it before starting stream. I not prepare for any longer and so on, so I will solve it in real time. We have initially like an array of zeros, like this one. We have 10 zeros, like equal to n. Then we have a list of operations with a range and operation that we need to apply to this range. For example, range is from 1 to 5, and we will need to add 3. So on the next step, on the range from 1 to 5, including both of them, we add 3. Next step, from range from 4 to 8, we add 7. So from 8 to 7 to 8, sorry, we add 7. And the last operation here is from range 6 to 9, we add 1. And after doing all of these operations, we need to find the largest number in final set. The larger number is 10 after all operations. One of the ideas that the array itself is not required by the task. We don't need the array itself. We need only one number, like this one, 10. So, what constraints we have? The maximum length of array itself, it will be up to 10 million. Minimum of 3 items, but maximum of 10 million items. Then we have is the second number, right? M is amount of operations, right? We have from 1 to 200,000 operations on this array. And the last thing, that the range will be starting from A to B, so like from 1 to 5, and they can be equal, so range can include only one number, and maximum value is the last item, so less than n. And the value by which we will change the numbers here is from 0 to 1 billion. And we need to return only one integer. Just by observing our constraints, they are big enough, it's possible to understand that our solution should have complexity of n. Otherwise, it will work too slow and possibly will not able to complete the task in the time. So let's think what is possible to do with this. The first obvious solution like the clearer one, is to initiate an array and then just starting to apply the operation for each cell in the array itself. But like if we will have big ranges and a lot of operations, which is possible, we'll have up to 200,000 operations, we will need to apply, like in worst case, every operation will took n time, since we will apply it to every cell and like it doesn't worth it. So the complexity of the possible complexity of this solution will be n multiply to m. Yes, n multiply to m, which is a lot. We do every operation just once, then go through the array and find the largest number. Okay. Like for every operation, do so. Winston, yes, well, something like that. Something like that. So, but that doesn't sound good to me. Since we have only range of perform some operation and we need to find a maximum number, maybe it's probable to operate with ranges itself somehow. Let's think how we can do this. Maybe we can start something. So maybe we can start with the array itself, with empty array, and two indexes like this. First of all, we will add something to index 1 and something to index 5. So we will start with we will go through this array at the end, and we'll I think the complexity that I told before with the first approach was not proper one. I think it will be higher than mn. It should be calculated more properly, but okay. Let's go anyway with the second approach. It looks easier for me. So we will start counting from here and see any other operation than starting inside of this. So like we will put here some subarray like with number 3, and at position 5 we will have something like AND array, I don't know, which will remove all the numbers from our sequence. So for example, we'll put 3 here, we'll put 7 to position 4 and to position 8 for 8. We'll have 7 here, and from 6 to 9 we'll put 1 and 1 here. So when we will go through an array, we will find first that we have 3. Okay. Then we found 7. We sum this number, we have 10. After this, we go to -3, so it will be again 7. Then we make +1, so 8. The previous maximum number was 10. So during all the time we will memorize our maximum number, and in the end we will just return it. So as for me it looks good. At least it should have like not big complexity. The maximum will be m to n, so we anyway need to go through all the operations, right? Through all the operations at least once. Originally maybe it will be not m multiplied to n, but m plus n, which is much better. So, sounds good. Sounds good. Okay, let's start to write our function. We have n with which is array size. Let's rename it to array size. Let's create an array. So we create an empty array of this size. We have a maximum value of 0. Since we start from 0, it's not possible to go for numbers less than 0. So sounds good. Sounds good. Then we go through queries. For which we need to see what these queries have inside. Let's see for a second. So we have 3 numbers, right? 1, 2, 3. And one of the things that the numbers is 1 higher than our index, since our index starts with 0 and not from 1. So we have, or just for make it easier, we can just add 1 to array size. Another thing that I need to mention, that it's possible that we will not able to be in integer range. I mean, if we will summarize all the numbers, we possibly will go out of integer range, and we will need to use some mathematical library that represent numbers as string, or use that double instead of integers or something like that. There is some libraries even for JavaScript for this, but we will start without this, and we'll add the subpart of this only if there will be requirement, because this platform only give ability to use some special libraries, and I don't remember which ones. So I just need to mention this. So we have 3 numbers. I will add 1, so I will not care about the changing index from this side. So we'll have 0, which will be 0, and it doesn't matter. So originally maybe it's better to have something better, but this will help to avoid possible problems regarding coding and changing the index itself. So we have start range, end range, and value. Start range, end range, and value. So for our array at start range, first of all we will need to create an object. I want to start with an object like this, and the object will have operations start operation and end operation, which will be 0 initially. The same thing we will do for end range, start and end. So for end we will it will be like minus operation, start it will be like plus operation. And now we will add our values here. So it will be to the start one. We will add our value. For both of them, originally we will add our value, and that's all. Okay, looks simple. Looks simple. So for both of these objects, we add our value. Then we don't need the max value. Okay, no, let's have max value from the start. That will be a bit easier. And then we return max value, and now we will need to go through our array to perform all operations. So we will go through every element and we'll check if there is value. So that means that at least it's object or something like this. We also need the current number. Let current number. We will increase current number with not the value, let's rename it. I don't like value. This is bad name since it's not value. I will need to write something like value start, which I doesn't like. Let's call it at least cell. It's not a good name also, but it's better than value since value is like value, and I expect that value to be value. Then we compare current number with max value. If it's higher, then max value will be equal to current number. After this, we need to remove from our current number cell end ones. So let's see what we'll have. We can also try to test our code by ourselves by just going through it manually, which is not a bad idea for me. So okay, it's a bit messy, but anyway, we'll go through this. So we create an array. If there is 10 elements, there will be an array of 11 elements, which is fine. We don't need to change an indexes and so on, and one element of 0 length will not affect anyhow. We putting in the cells, so we put in the cell 1 and 5 object like this. At 1 we will have start 0. At 5 we will have end, sorry, no, not 0, start 3 and 3. We will add it by this part. At the cell number 4 will have start 7. At cell number 8 we will have end 7. and that cell 6, start 1, and that cell 9, end 1. So after this, we go through our cells. If there is some value, so it's not null, not 0, and so on, we will add to current number cell start. Then we will compare that it is higher than max value. We'll assign it. Then we'll add like end operation. Okay, and we return value. So it looks good to me. We can try to run code at least on test data. Let's see. Wrong answer. Our output is 0. What means that we doesn't change max value at all. And expected was 200. Okay, I will need to see what we have in array. Originally it may be possible on interview or something like that. By some reason it's string. What is this? My God. Something very strange. Let me just check what we have at start, just to be sure what we create. Okay, 6 empty items. Then we start adding some values. Looks like I wrongly understand incoming what is inside queries itself. So we'll need to take a look what we have inside of queries. So we have like 1 to 100. We have an array. Okay, and I had used just an arguments. Okay, it's a mistake that I didn't put additional symbols to take the values from the array itself, and I just use an arguments. But it's not a real array, but it's possible that on many interview will be penalized for such errors. So better to write proper code from the start. But let's see. Like algorithmically, I presume that everything was right. It should be right. I don't know why it took so long for uploading. We still have something really strange here. I presume the problem of this that no, the queries should be a number. But originally it just looked like that it like string here. So, oh my God, we need to add it to start and to end one. Problem not with the string or something like that. There was super simple problem that yep. Okay, so let me just explain. I forgot to use keys. Like I add them here, but I don't use them when I add the value itself. Let's submit code and see, will it work? Yes, it worked for all cases, and I presume we got higher score. Yes, we got all 60 points. So with few mistakes, yes, it happens sometimes. I told it always, like, next time I will try to take care of these small mistakes, but originally when you just work and not to solving problem like this, you are used to make some small mistakes, since you can fix them very fast. So let's find out our space complexity and time complexity. Space complexity is how fast memory consumption grows. Time complexity is how fast CPU consumption grows. It means that not just how many CPU memory we used, but how fast the changing of memory, how fast the memory will be changed depending on the incoming variables. So if array size will be higher, if we will have more queries, and so on. Like how all of this will be changed. Let's go inside and see. We'll have space, let's call it as C. Space complexity of our array size. Here, since we create an array, inside this array we will create an elements and objects. But since it fixed size, it doesn't increase the amount of keys or doesn't store a lot of values and so on, it will be 1 here. So it doesn't change the space complexity. It doesn't have any other ones. So we have space complexity of, I presume it will be n, right? Yes, n is the number of elements in your array. Then we go for time complexity. For time complexity, originally creating an array already will take n time. So we already have O(n) by creating an array. Then we go through our queries. The cycle itself will have complexity of queries length. Queries length. Queries length is the second number, which just called queues here, right? Which called m. Okay, m number of operations. Let's write like as from input. So we have m. Here inside, all of the operations just assigning variable, and it's assigned once. The complexity of this is 1. So we still with OM here. Then we go through our array, ON, and so we'll have ON again here. And we perform operation on every cell. This is simple operations, and they have complexity of 1, since we just assign variable, we modify variable, we compare it with max value, change another one, modify it back if it's required, if we have end values and so on. So it will be 1 inside. So at the end, we have time complexity of n plus m. Maybe it's possible to get rid of n later on, somehow. I presume that it's possible to work just with chains itself. So instead of creating like a big array from the start. But originally, in the worst case, we anyway will put a value to every cell. So it will be the same, right? Let's take a look at constraints. We have amount of operations of 200,000 and we have 10 millions of cells. So no, it's not possible to have operation on in every cell. Even we have start and end, it will be 400,000 since it's possible to be another ones, and it's still less than the size of array itself. So maybe it's possible to do something with linked list, I don't know, but maybe there will be a larger time for the searching where we need to insert or new range. So I'm pretty happy for now with this, but maybe it's possible to go to something like OM, which is list of operation, but I'm not sure. For this task, I think we are done, and if someone will want to try to optimize this, I mean to me to optimize this, or you can do this, write in the comments and I will get back to this task later on. So we end with this task, done with it, and go back with to one of the tasks that we had solved some time ago with a chessboard. And we had solved it with space complexity of n square and time complexity of obstacle count plus size. And the idea was to change it to space complexity 1 and time complexity just obstacle count without a size. So let me remind the task itself. We have a chessboard, we have a queen, and we need to count how many cells we can attack by the queen. Also, we have some obstacles on the board, and if there is an obstacle, it's obvious queen cannot move beyond this obstacle, so it blocks some amount of possible attack cells. All of this, so it can stay in corner and so on. And my idea is to start with all possible ways to count amount of cells just by calculating distance, then go through all obstacles to see if these obstacles is on the way to queen, and if it on the way to queen, we will reduce the number from this direction to the queen. So we have what we have here already. I didn't remember anything already regarding this task. So let's see. We have obstacle coordinates. We do something with that. We have directions. I think the directions we'll use this one later. So this looks useful. We go through all directions to check something. So I just want to remove everything from here, and let me just leave these cells. And also I doesn't think that we need this one. Okay, and we'll left only with the directions. With directions, I will need to calculate the distance from the queen to end of the board. Instead of array like this, I will have array of directions itself. By name. So we'll have something like down left. So it's possible to copy from here. Yeah, nice. So we'll copy all of this. By some reason no, it's possible. It's possible to do like this, but it should be on the line. So like this. So initially it will be 0, but not 0. We have queen row, queen call, and we have size. So go down mean the difference. I think size is go up and not and down. To go down, we will need to see what is queen row and remove 1 from this. So down it will be queen row minus 1. So for example, if the queen row is 4, then we have 3 cells here, right? If we go up, then we will remove, for example, if we are on the first position, we have size 4, we remove from 4, current position 1, and we will left up with 3. So let's go with the top one. We remove from the size queen row. Okay. Now we can make with left. With left, it again we can go with how it called, queen column minus 1. It will be to the left minus 1, and to the right it will be size minus queen column. So for this example, if we stay at the top right corner, to the right there will be like 0 cells. So 4 minus 4 is 0 and everything is good. It will be a bit complicated for the diagonals, but probably it will not so hard. So I presume that we need to choose the smallest one from down and left and go with this, and it will be diagonal value. Since we have like 3, 3 and diagonal will be 3. If we have like 2 and 3, we go with 2. So we will go with smallest value. Maybe it will be good to do it in second operation, like to have like directions. Sorry. Directions down left. My God, what is wrong with this? So then top left, top right, down right. Okay, and down left will be the smallest number from down and from the left. Directions down. Let me call it like this, and switch from the array view to like object way to name all of this. It should be barely the same, but just to change like top left, top right, and down right, so like this. So we have calculated directions for all of them. Our last operation will be go through all of them. So let's write it, since it's like obvious operation. Object keys of directions. We go through the name, direction, and we will add to our cells the amount of cells from these directions. Like this. It's possible to write in line. Let's do this. Like this. Okay, nice. And before we do this, we need to modify. Also, we can use reduce instead of for each and just return it. What do you think? Let's use reduce. We'll start with 0. We'll have 2 values here. One of them is sum, the second is direction, and we will return sum plus direction. Let's do something like this. So we'll don't need the cells variable. So we need to go through our obstacles now. Let's remove this one. No, maybe we will need this one. Maybe not. We'll see. So we will go through our obstacles. Oh, sorry. What we have inside obstacles itself, I presume that it will be a pair of coordinates. All right. Two-dimensional array of integers where each element is array of 2 integers. Row and column. So this time I don't make this error. So row and column. I mean, this time I not forgot to work with this as an array and not as arguments. So we'll have rows and columns, and now we will need to check are we on the queen attack directions. So we will need to determine direction itself. First of all, if a row or column are equal to one of the queen, that means that we are on vertical or horizontal direction. If the difference between originally, maybe we can start with differences from the start. So, yep, looks like we will end up with something like this. We can let me think for a second. We can just compare queen row with the row, but how? Maybe we can remove it, for example. Just let me think out loud and see what we can do with that. So we have queen row minus row. If it will be 0, it means that we are on the same row. The same with column. Yes. We also possibly can divide, but what it will give to us if we will divide, I'm not sure. Okay, so if we will remove a row and we will remove a column, if there is some of them 0, that means that we are on horizontal or vertical. And for diagonals, for example, if we have 3, 3, and we will have 1, 1 at the end, right? Or minus 1, minus 1, which will, yes, we'll have minus 1, minus 1, which will determine down left. But what if the position will be like here? Or if we have 2, 2, we'll have minus 2, minus 2, right? And I presume let's think. If we have minus 2, minus 2, we can still count it as minus 1, minus 1. The only thing here that they are equal to each other in mean of absolute value. So yes, for example, if we'll have queen here and we will need to compare absolute values, that will mean that we are on the proper direction, and then if it on direction, we will determine which one. So let's just start write code and see what will be here. So we'll have current direction, which will be null initially. Then we will write code like, let's have 2 additional like constants, like a row diff, yep, like this, and we will compare something here, and do something with current direction. First of all, if row diff equal to 0, or call diff equal to 0, no, let's start if both of them can be not 0. So let's start with some directions and we'll add the other ones. If we have the row difference, then we need to determine it is from the left or from the right. So current directions will be equal if call difference greater than 0 will means that there is mistake, sorry. If column difference, let me just add the two values here. If column difference is greater than 0, that means that the obstacles is from the left, right? From the left, yes. So we have left. Possibly I do something wrong here, we will fix it later, just want to not take too much time for this. Then if we have column difference of 0, we'll have barely the same but with the rows. So if a row we remove from the queen the number of obstacles, so it will be positive, then it's mean down, otherwise top. Then how we can see that we have diagonal here? The absolute values should be the same. So let's start with this approach. The absolute difference math ups of row diff is equal to math ups call diff, and if it's same, then we can start to determine what is the direction. We will do it barely the same by comparing call diff which will tell us is it left, so left, otherwise it will be right. Here inside we will do the same with the row, so it will be down, otherwise it will be top. So we'll have same thing here. we can put this logic here and just modify the variable twice. So we have left, right, and down, top. So first of all, we add this to our current direction. Current direction will be equal to down. Here it will be equal to top. And then we will add the left here. So we'll end up with down left or down right. Down left or down right. So we find our direction, and this only first part. Now we need to see how far it is from the queen. How far obstacle is from the queen. We need to find maybe we can start with the distance inside the code also. So let's do it like this. So we have current direction, and we will also have distance, which will be not a 0, infinity. So let's start with infinity, since the distance should be no, we can start with null. It doesn't matter, we will calculate it anyway. Infinity might be useful in some other parts and so on. So distance here will be absolute value of column difference. Same for the row difference. And for diagonals, it doesn't matter which one we will took. Alright, since it's diagonal, and it should be equal. For example, if we will stay here, and we have here the row and column difference will be the same. What about if we have no, it will be the same. It will be the same. So we have distance. Let's just set it here. And now we will see if in our directions, with current directions, if our distance is lower, than this one, then let me just think a bit. If we will have something like this, and we have difference of 1, right? Distance of 1. And from here we also have distance of 1. So we need to remove also 1 from here. Now let's just duplicate code for now. Maybe we'll optimize later, but not today. So if distance is less, then we will set this distance. Okay, maybe there is some errors, but Please. It fails on something, but at least two of these calculated properly. Call is not defined, line 65. Okay. It's not a big problem. We can just rename this one. And yay! Let's run all the cases and see how it will work. It works. Yes. Oh, okay. Just one small mistake of naming column instead of call and using the different name, but it's like not a big problem. So let's see our space complexity. We have one object of directions, like with the all directions, with 8 of them. We doesn't store any other objects or like this, so we came up with space complexity of 1, as it was discussed initially. For time complexity, we go through all the obstacles, which mean we have at least obstacle count complexity, and here inside all of operation have complexity of 1, alright? And at the end we go through our direction, which is also fixed size, so 8 of them, and just sum the numbers. So we end up with time complexity of O obstacle count. How it called? Obstacle count is there some initial letter for this? K? Yes, K. Okay, so time complexity will be O. Okay. Space complexity will be 1. So very nice. We optimize it, and I presume that it's not possible to do it more efficient in mean of time complexity. Maybe it's possible to optimize this part to looks better. So maybe I think we will not return to this one since it's solved by optimal way. So okay, thank you for watching and have a nice day.